Hi, I'm Mina.
And I'm Yules.
Thanks for tuning in to Artificially Informed.
When you think about the most intense, high-stakes environments imaginable, your mind usually goes to something physical.
Right, yeah, like something really visceral.
Exactly, something visceral. So picture the Artemis II spacecraft right now.
Oh, wow, yeah. That is the definition of high stakes.
It really is. It is this tiny, heavily engineered cone of metal, and it is just slamming into the Earth's atmosphere at roughly Mach 32 after, 10 days in deep space.
10 days, yeah.
Yeah.
Which is just an unfathomable speed to try and comprehend.
Right. So to put that in perspective for you listening, that is roughly 25,000 miles per hour.
It's just staggering.
And the ablative heat shield on the bottom of that capsule is glowing at like 5,000 degrees Fahrenheit. The plasma trail behind it is so intensely hot and dense that it literally physically blocks all radio communications.
Yeah, the blackout period. That has
Yeah.
to be terrifying for the ground crew.
Oh, absolutely. For several agonizing minutes, Mission Control is completely blind and deaf to the crew. It is this violent, roaring, perfectly calculated re-entry.
Yeah.
It is the absolute edge of human capability. But it is entirely governed by the comforting absolute laws of physics.
And what's really crucial to understand about that re-entry is, well, it's the physics of kinetic energy.
Okay, how so?
So that spacecraft cannot simply hit the brakes in a vacuum. All of that forward momentum built up from falling all the way back from the moon, it has to go somewhere.
Right. Energy can't be destroyed, just transferred.
Exactly. The spacecraft is essentially using the Earth's atmosphere as a giant friction-based brake pad.
A brake pad. That's a great way to think about it.
Yeah, and the heat shield isn't just absorbing heat. It is literally designed to burn away, carrying the thermal energy off and away from the crew cabin.
Okay, wow.
It's incredibly complex, but as you said, it's predictable. Thermodynamics, fluid dynamics, orbital mechanics, they don't suddenly change their minds. They don't decide to negotiate.
Right, they're absolute. But then I want you to simultaneously juxtapose that image of the Artemis II splashing down in the Pacific Ocean with a very different kind of high-stakes environment currently unfolding in the news.
Okay, where are we going?
Imagine a quiet, heavily guarded, air-conditioned room in Islamabad, the capital city of Pakistan.
Ah, right, the Hormuz talks.
Exactly. Inside this room, delegates from the United States and Iran are sitting across a table from one another, completely deadlocked over the control of the Strait of Hormuz.
Which is incredibly tense right now.
It really is. And there are no absolute laws of physics in that room. It is entirely subjective, It's volatile and driven by human friction, historical grievances, and economic leverage.
And arguably, the tension in that quiet room in Islamabad could have a much more immediate, chaotic impact on the daily lives of billions of people than a spacecraft re-entering the atmosphere.
Wait, really? More than a space mission?
I mean, think about it. If the calculations on Artemis II fail, it is a localized tragedy for the crew and a huge setback for science.
Right, which is terrible, but contained.
Exactly. But if the calculations in that diplomatic room fail, you are looking at a global economic contraction. You're looking at skyrocketing energy prices and the potential for a sprawling regional conflict.
So it's the ultimate contrast, the precision of the cosmos versus the absolute unpredictability of human nature.
Precisely.
And that contrast is exactly what we are exploring today. Welcome to this deep dive. If you've been trying to make sense of the overwhelming flood of global headlines lately, well, you're in the right place.
We've got a lot to cover today.
We really do. Our mission today is to unpack the forces of expansion and contraction happening all around you. We are looking at the literal accelerating expansion of the universe itself and humanity's physical pushback to the lunar surface.
But we aren't just looking up.
No, we are diving down into the deep geological forces shaping the crust of our planet. We'll look at the ancient historical migrations that defined our species and the current tightening geopolitical bottlenecks that are threatening to choke the global economy.
Yeah, we've been analyzing a massive stack of recent international reporting, pulling from astronomy, archaeology, climate science, and global geopolitics.
Right. The goal is to synthesize these seemingly disparate events to give you a comprehensive map of what is actually happening on and off Earth right now.
Because when you put these pieces together, you start to see the hidden machinery of how the world operates.
You really do. You start to see how, like, an ancient Chinese map relates to modern shipping lanes, or how the loss of an African forest impacts marine life in California.
It's all incredibly interconnected.
So let's start by looking outward At the macro level, the Artemis II mission.
A huge milestone.
Huge. After 10 days in space, the crew has successfully splashed down in the Pacific. This was the first crewed flight around the moon in over 50 years.
And they set some impressive records, too.
Yeah, they set a new record for the furthest distance humans have ever traveled from Earth. They officially surpassed the record set by the Apollo 13 crew back in 1970.
Which is just wild to think about.
It is, and the imagery that has been transmitted back is just staggering. They witnessed a rare solar eclipse from beyond the moon looking back toward the sun.
I saw that. It's beautiful.
There is this one photo circulating in the news wires of the Earth and the moon in the exact same frame, bathed in the same distant sunlight. It really gives you a profound sense of scale.
It really does put things into perspective.
But help me understand the actual logistics here. Because if this mission was essentially just a giant loop around the moon without actually landing, what was the real objective?
Right. Why spend the money?
Exactly. Was it just a multi-billion-dollar photo op?
Not at all. Artemis II was essentially the ultimate high-stakes stress test.
A stress test. Okay.
Yeah, the primary objective was to push the Orion spacecraft and the Space Launch System, what NASA, the National Aeronautics and Space Administration, refers to as the SLS, to their absolute limits with human lives aboard.
Because the next mission is the actual landing, right?
Exactly. You have to look at the timeline. Artemis III is the mission slated to actually put boots back on the lunar dust. But before you can do that, you have to validate the foundational architecture.
So they were testing the basics.
The basics, but the incredibly complex basics. Artemis II was entirely about testing the environmental control systems, the life support, the thermal regulation, the manual navigation, and the deep space communication arrays.
And doing all that in an environment where rescue is literally impossible?
Exactly. You are on your own out there.
Okay, that makes sense. It reminds me of like taking a brand new car to a high-speed test track.
Oh, that's a good analogy.
Right. If a car company builds a prototype, they don't immediately sell it to a family for a cross-country road trip through the Mojave Desert.
No, that would be disastrous.
They take it to the track, they redline the engine, they slam on the brakes, they take corners too fast, and they see what shakes loose. So, if Artemis II was the test track, what were the specific catastrophic failures they were actively hunting for?
That's a very solid way to look at it. But on a test track, if the brakes fail, you hit a foam wall.
True.
In deep space, if the systems fail, the environment is instantly lethal. They were rigorously testing the closed-loop life support system.
How is that different from, say, the space station?
Well, in low Earth orbit, on the International Space Station, if a carbon dioxide scrubber breaks, you can just send up a replacement part on a supply ship in a matter of hours. Or, worst case, the crew jumps in a return capsule and comes home.
Right. They're just a few hundred miles up.
Exactly. But 250,000 miles away at the moon, you don't have that luxury. You have to know with absolute certainty that your systems can scrub the CO2, regulate the humidity so water doesn't pool on the electronics, and manage the extreme thermal loads.
Wait, expand on that thermal load aspect. Because space is just cold, right? Why is heat a problem?
That is a very common misconception. Space itself doesn't actually have a temperature because it's a vacuum.
Oh, right. There's no air to hold the heat.
Exactly. There is very little matter to hold heat. The problem is solar radiation. When the Orion spacecraft is in direct, unfiltered sunlight, the exterior temperatures can exceed 250 degrees Fahrenheit.
Wow, okay.
But the side of the spacecraft facing away from the sun, plunging into shadow, drops to minus 250 degrees.
So you have a 500-degree temperature differential across a metal hull.
Yes. The spacecraft's thermal management system has to actively pump fluids around the hull to distribute that heat, keeping the internal cabin at a comfortable 70 degrees, while the exterior is being simultaneously roasted and frozen.
That is terrifying. If that system fails, the crew either bakes or freezes in hours.
Oh, there is zero margin for error.
And beyond the intense hardware tests, there seems to be a real, philosophical shift happening with this generation of spaceflight. One of the crew members gave an interview from orbit and said, taking care of space means taking care of Earth.
It's a really profound realization that inevitably hits astronauts.
Yeah.
Well, when we learn how to recycle every drop of water, how to scrub every breath of air, and how to generate sustainable power in the absolute dead, hostile zone of deep space, we are learning vital lessons about resource management.
Oh, I see, because you can't afford to waste anything.
Exactly. Space exploration is the ultimate exercise in managing a closed-loop ecosystem. And whether we like to admit it or not, Earth is just a much larger closed-loop ecosystem.
So that makes total sense. The technology we develop to survive out there directly translates to how we can better manage resources down here.
Precisely.
Speaking of looking out into the void, while the Artemis crew was navigating our local neighborhood, telescopes looking out into the deep, ancient universe, specifically the Hubble and the James Webb Space Telescopes, are sending back data that is causing a collective crisis in the astrophysics community.
Oh yeah, the Hubble tension. It's a huge deal.
Right, the reporting keeps referencing this Hubble tension. Now, I know the universe is expanding. We've known that since the 1920s.
Right. Edwin Hubble figured that out.
But the new data confirms it is expanding at a rate of roughly 73 kilometers per second per megaparsec. I will be honest, to me, and probably to anyone listening right now, that is just a very long string of science fiction words.
Last, I don't blame you at all.
What does that actually mean, and why is it a crisis?
It sounds impenetrable at first. Let's break down that unit of measurement because it is the key to understanding the crisis.
Okay, lay it on me.
So a parsec is a unit of distance. A megaparsec is 1 million parsecs, which is roughly 3.26 million light years.
Okay, so a very long way.
A very long way. So when astronomers say the universe is expanding at 73 kilometers per second per megaparsec, what they mean is this. If you look at a galaxy that is 1 megaparsec away from us, the expansion of space is pushing it away from us at a speed of 73 kilometers every second.
Right, every second.
Every second. And if you look at a galaxy that is 2 megaparsecs away, it is receding at 146 kilometers per second. The further away something is, the faster the fabric of space is stretching between us and them.
Hold on, let me stop you there. If the fabric of space is stretching everywhere, why isn't my living room expanding? Why isn't the distance between the Earth and the Sun expanding?
A very astute question. The expansion of the universe is a relatively weak force on a small, localized scale.
Small meaning like our solar system.
Yes. Inside your living room, the electromagnetic forces holding your couch together are vastly stronger than the expansion of space.
Oh, good, my couch is safe.
Your couch is perfectly safe. Inside our solar system, and even inside our Milky Way galaxy, the force of gravity completely overpowers the expansion. Gravity pulls the matter together tighter than space can pull it apart.
Okay, so where does it stretch?
When you look at the vast empty voids between distant galaxy clusters where gravity's influence is incredibly weak, that's where the expansion of space takes over.
Okay, so the empty space between galaxies is stretching, and we've measured it at the 73 number. Why is that causing a headache for physicists?
Because of how it conflicts with our other method of measuring the universe. The Hubble tension is fundamentally a crisis of conflicting measurements.
We have more than one way to measure this.
We have two very different ways to calculate the expansion rate. The first method involves looking at the very early universe, specifically something called the cosmic microwave background, or CMB.
Right, this is the leftover heat from the Big Bang, right? The static you used to see on old analog television.
Exactly. About 380,000 years after the Big Bang, the universe finally cooled enough for the first atoms to form, allowing light to travel freely for the first time.
So it's like a flash bulb going off.
Yes, and that first flash of light has been traveling through space for 13.8 billion years, stretching and cooling until it became microwave radiation.
Okay.
By studying the microscopic temperature fluctuations in that ancient radiation, cosmologists built a highly detailed standard model of physics. And according to that standard model, based on the early universe, the current expansion rate should be about 67 kilometers per second per megaparsec.
Okay, so the baby picture of the universe predicts a speed of 67.
Right. But the second method involves looking at the modern local universe. This is where the Hubble and James Webb telescopes come in.
And what are they looking at?
They look at specific types of stars called Cepheid variables. These are stars that physically pulse, expanding and contracting at a rate that is directly tied to their true intrinsic brightness.
Oh, so if we know how bright they actually are, we can tell how far away they are.
Exactly. By comparing how bright they actually are to how dim they appear to us on Earth, we can calculate their exact distance. We also use Type Ia supernovae, which are exploding stars that all detonate with the exact same peak luminosity. They act as standard candles in the darkness.
Standard candles, I like that.
So, by measuring how the light from these modern objects stretches, or redshifts, as it reaches us, we get that second number, 73.
So we have two tools. If I measure the length of a room with a traditional steel tape measure, and I get 10 feet, And then I measure the exact same room with a highly calibrated laser measure, and I get 12 feet. One of my tools is fundamentally broken.
That is the logical assumption, yeah.
Right. Are cosmic tools broken? Is there, like, dust on the lens?
For a long time, the astrophysics community desperately hoped the tools were broken. They assumed there was an error in the calibration of the telescopes, or that interstellar dust was obscuring the stars and making them look dimmer and therefore further away than they actually were.
It's easier to blame the tool than the theory.
Much easier. It's much easier to admit you measured wrong than to admit your fundamental understanding of reality is flawed. But the James Webb Space Telescope was explicitly designed to be so incredibly precise, operating in the infrared spectrum to pierce through that cosmic dust, that it would permanently eliminate those measurement errors.
And what did it find?
Webb has confirmed Hubble's numbers. The measurements of the modern universe are incredibly accurate. The tools are not broken.
Which means the universe is just acting incredibly weird. If the early universe says the speed should be 67, and the modern universe definitively proves it is 73, what is the implication here?
The implication is massive. It strongly suggests that our standard model of cosmology is missing a massive piece of the puzzle.
Like what?
If the universe is expanding significantly faster today than the laws of physics predict it should be, based on its early conditions, it means there is some undiscovered physics at play.
Undiscovered physics. Wow.
Yeah, there might be an exotic early form of dark energy that gave the universe an extra push shortly after the Big Bang. Or maybe our understanding of how gravity operates on a cosmic scale is just incomplete.
So the textbooks need a rewrite.
The Hubble tension means that the textbooks on fundamental physics are going to need a major revision.
Just to add a little more chaos to the cosmos, the reporting also highlights some incredible new data about a supermassive black hole.
Ah, yes. The cosmic volcano.
Yeah, they observed a galaxy cluster known as J1007 plus 3540. The scientists described the black hole at its center as a cosmic volcano that just woke up after 100 million years of absolute dormancy.
It's a spectacular event.
And when it woke up, it blasted jets of superheated plasma a million light years across its surrounding galaxy cluster. Let's just pause on that scale.
Right.
Our entire Milky Way galaxy, containing hundreds of billions of stars, is about 100,000 light years across.
Right.
This black hole shot a jet of fire 10 times the width of our entire galaxy.
Yeah.
How does a supermassive black hole just, wake up after 100 million years? Do they just suddenly get hungry?
In a cosmic sense, yes, they get hungry. But we have to clarify what a black hole actually is. It's not a physical hole in space.
Right, it's an object.
It is a region of space where matter has been packed so densely that its gravitational pull is so intense that not even light can achieve the escape velocity required to break free.
Okay.
Now, a supermassive black hole isn't always actively consuming material. If the space immediately surrounding it is empty, it sits there, dormant and largely invisible. But galaxies are dynamic.
Things move around.
Exactly. If a massive cloud of cold interstellar gas, or perhaps a wandering star, drifts too close, it gets caught in that immense gravitational well.
And it falls in.
It doesn't just fall straight in. It spirals inward, like water circling a drain. As this massive amount of gas and dust compresses into a tighter and tighter orbit, it forms what is called an accretion disk.
And the disk gets hot, right?
Unbelievably hot. The friction of all this material grinding against itself at significant fractions of the speed of light generates unfathomable heat. We are talking millions of degrees. The atoms are stripped of their electrons, turning the gas into a turbulent plasma.
But wait, if a black hole's gravity is so strong that not even light escapes, how on earth is it blasting a jet of plasma a million light years outward? Shouldn't it all just be sucked down the drain?
That is the brilliant paradox of these cosmic volcanoes. Not all the material in the accretion disk crosses the event horizon, the point of no return.
Oh, it escapes before it falls in.
Exactly. The spiraling superheated plasma generates twisting, incredibly powerful magnetic fields. These magnetic field lines get wound up tighter and tighter near the black hole, acting like an enormous cosmic particle accelerator.
So it shoots it out the poles.
Yes, they funnel a portion of that infalling plasma, accelerate it near the speed of light, and blast it outward from the black hole's rotational poles.
So it's essentially a cosmic blowtorch.
A blowtorch of unimaginable scale, yes. But what is truly vital about this discovery in J1007 plus 3540 is understanding the role these massive jets play in the life cycle of the universe.
They do something besides just destroy things.
They aren't just destructive beams of radiation. They serve as a mechanism for galactic regulation. Imagine the galaxy cluster as a giant bowl of soup.
Okay, soup.
The black hole's jet acts as a massive mixing spoon. As these jets blast through the galaxy cluster, they churn through the cold interstellar gas. They heat it up, and they distribute heavy elements, like carbon, oxygen, and iron, which were forged in older stars far and wide across the galaxy.
Why does heating up the cold gas matter?
Because stars are born from cold gas. If a cloud of hydrogen gas is cold and dense, its own gravity causes it to collapse inward, eventually igniting nuclear fusion and birthing a star.
Oh, I see.
But if the black hole's jet heats that gas up, the thermal energy causes the gas to expand. It becomes too hot and energetic to collapse. So by blasting these jets, the black hole is essentially acting as a colossal thermostat for the entire galaxy cluster.
Oh, wow.
It physically prevents the runaway formation of too many stars. It regulates the growth of the galaxy itself.
Okay, so we've got the very fabric of the universe expanding faster than physics says it should, and dormant black holes waking up to regulate star formation with million light-year blowtorches.
It's a busy universe.
It really is. But let's bring this back down to Earth. Because to survive, study, and navigate in these extreme environments, human beings are being forced to engineer some truly mind-bending breakthroughs in physics right here.
We are seeing some incredible leaps in material science.
Let's look at navigation. The news this week covered a massive breakthrough regarding thorium nuclear clocks.
This is a huge deal for navigation.
Right. A research team out of Xinjiang, China, has managed to synthesize a highly specialized ultraviolet crystal. The reporting states this crystal operates at a highly specific wavelength of 145.2 nanometers, and that this specific crystal is the missing key to creating GPS-free thorium nuclear clocks.
Which is a lot of technical jargon, but the implications are huge.
Exactly. Now, to the average person who is just trying to navigate traffic on their smartphone, the current GPS system already seems like absolute magic. You type in an address, and a satellite tells you to turn left in 400 feet.
We completely take it for granted.
We do. Why are physicists going through the incredible trouble of measuring the nucleus of a radioactive atom just to tell time and location?
Because the satellite-based global positioning system, GPS, is actually shockingly fragile and vulnerable.
Fragile? How?
We rely on it for everything from civilian aviation and maritime shipping to banking transactions and military targeting. But your phone, or an aircraft's navigation system, relies on receiving a faint radio signal from a constellation of satellites orbiting roughly 12,000 miles above the Earth.
That's a long way for a signal to travel.
By the time that signal hits the surface, it's incredibly weak.
Which means it can be messed with.
Exactly. It can be easily jammed by a localized transmitter, completely blinding navigation systems in a specific area. It could be spoofed by malicious actors, feeding false coordinates to a ship or a drone.
So it's a major security risk.
Absolutely. Furthermore, GPS radio signals cannot penetrate deep water, so they are completely useless to submarines navigating under the polar ice caps. And, as we discussed with Artemis, there's no GPS constellation orbiting Mars or the moons of Jupiter.
So if we leave Earth, we have no GPS.
Right. If we want to navigate in deep space or in contested military environments on Earth, we need a hyper-accurate way to determine position that does not rely on an external satellite signal.
But how does a clock tell you where you are? I understand how a compass works, but how does telling time equate to physical location?
It comes down to the speed of light. GPS doesn't actually tell you where you are. It tells you what time it is.
Wait, really?
The satellites broadcast a timestamp. Your receiver picks up signals from multiple satellites, compares the exact time the signal was sent to the time it was received, and calculates the distance based on how long the signal took to travel at the speed of light.
Oh, that makes sense.
By intersecting the distances from 4 or more satellites, a process called trilateration, it pinpoints your location. But to do this accurately, the clocks have to be accurate to the nanosecond.
So we already use atomic clocks on those satellites. What makes a nuclear clock different or better?
It's a matter of scale and stability. Current atomic clocks, the ones we've used for decades, measure time by observing the transitions of electrons orbiting the nucleus of an atom, usually cesium or rubidium.
Okay, looking at the electrons.
They use microwave frequencies to cause the electrons to jump between energy states, and they count those jumps like the ticking of a pendulum. They are incredibly accurate, but the electron cloud is relatively large and sensitive.
Sensitive to what?
It can be disrupted by stray magnetic fields, temperature fluctuations, or electromagnetic pulses. A nuclear clock, specifically one utilizing the isotope thorium-229, doesn't look at the electrons. It measures the tiny energy transitions happening within the atomic nucleus itself.
Which is much smaller.
The nucleus is roughly 100,000 times smaller than the electron cloud. Because it is so unimaginably compact, it is heavily shielded from outside interference. It is virtually immune to magnetic fields or environmental changes.
So it's a much more robust, unbreakable metronome. But why did we need the specific crystal from China?
Because you can't use microwaves to trigger a nuclear transition, the energy required is too high. You need a highly specific frequency of ultraviolet laser light.
And we didn't have that before.
For decades, physicists knew thorium-229 had this unique property, but we simply did not possess a material capable of efficiently generating that exact 145.2 nanometer UV laser. We knew the lock, but we couldn't forge the key.
And this new crystal is the key.
This new fluorinated boric crystal from the Xinjiang team solves that critical bottleneck. It means we could soon miniaturize this technology. You could place a highly portable, hyper-accurate nuclear clock on a submarine, allowing it to navigate submerged for months using dead reckoning, or guide a deep space probe past Saturn with pinpoint precision entirely independent of fragile satellite links.
And we aren't just revolutionizing how we navigate. The reporting shows we are fundamentally altering how we manufacture the physical world. There are two major materials science breakthroughs highlighted here.
The superatoms and the steel.
Right. The first is the creation of what they are calling giant superatoms to solve quantum computing hurdles. The second is a new 3D printed, super strong steel that literally never rusts.
If you synthesize these breakthroughs, you are looking at the foundational architecture of the next industrial revolution.
Let's look at the steel first, because rust, or iron oxide, costs the global economy trillions of dollars annually, right?
Trillions. It degrades our bridges, our ships, our offshore wind turbines. By developing a 3D printable steel alloy that inherently resists oxidation while maintaining immense structural integrity, you completely change the economics of building infrastructure in extreme environments.
Like the deep ocean or space.
Whether that's a deep-sea drilling platform or the structural struts of a lunar habitat.
And the superatoms.
Ah.
I know quantum computing is always heralded as the next big thing, but it always seems to be like 10 years away. What is a superatom and what hurdle is it actually clearing?
The primary hurdle in quantum computing is a phenomenon called decoherence. Traditional computers use bits, representing either a 0 or a 1.
Right, binary.
Quantum computers use qubits, which, due to the bizarre rules of quantum mechanics, can represent a 0, a 1, or both simultaneously. This allows them to perform incredibly complex calculations at unimaginable speeds.
But there's a catch.
A huge catch. Qubits are incredibly fragile. The slightest change in temperature, a stray cosmic ray, or a microscopic vibration can cause them to lose their quantum state. That's decoherence. They crash.
So they are hard to keep stable.
Very. The reporting discusses the creation of giant superatoms, which are essentially clusters of atoms engineered to behave exactly like a single massive atom. By using these superatoms as the building blocks for qubits, researchers are creating a much more stable, insulated environment.
Oh, because it's bigger.
The larger atomic structure acts as a buffer against environmental noise, significantly reducing decoherence.
So they are building tougher qubits to make the computers reliable.
Precisely. And it creates a compounding loop of innovation. When we finally have stable, large-scale quantum computers, we will use them to simulate molecular chemistry at speeds impossible today.
Which means we will use the quantum computers to invent even better supermaterials.
Exactly, which will let us build better computers. It is an accelerating curve of technological capability.
It is truly staggering to think about. But as much as we look up at the expanding universe and down into the invisible quantum realms, we have to look down beneath our feet.
Back to Earth geology.
Let's transition from the cosmic and atomic scales down to the deep Earth, because the geological forces moving the crust of our planet are just as dynamic. We have a fascinating piece of reporting here regarding geology. Scientists have finally decoded the mechanism behind Earth's gold kitchen.
Yes, this is a brilliant piece of deductive geology.
Okay, so set the stage for us.
For a very long time, geologists and mining conglomerates knew that volcanic island arcs, which are chains of volcanoes formed above subduction zones, like the Aleutian Islands or the Japanese archipelago, were incredibly rich in gold and copper deposits.
So we knew the gold was there.
We knew it was there, but the precise mechanical and chemical process of how the gold migrated from the deep, solid mantle up to the shallow crust in such highly concentrated veins was hotly debated.
And the recent data explains that it comes down to something called hydrous minerals, basically water-bearing rocks. let me see if I have this right. A subduction zone is where two massive tectonic plates collide, and one is forced underneath the other, diving deep into the Earth's mantle.
Right, it's getting pushed down.
As that plate sinks into the abyss, the extreme heat and crushing pressure cause the hydrous minerals inside the rock to destabilize, and they essentially sweat out their water.
That is exactly right. But this isn't water like you would find in a glass on your kitchen counter. Under the immense pressure and temperature of the mantle, the water enters a supercritical state.
Supercritical. Meaning what?
It becomes an incredibly aggressive, highly effective chemical solvent.
And this supercritical water acts as a catalyst.
It does two crucial things. First, the introduction of this water significantly lowers the melting point of the surrounding mantle rock. It induces melting, creating the buoyant magma that will eventually rise to fuel the volcanoes above.
Okay, and the second thing.
Second, and crucially for the gold, this supercritical water readily dissolves trace amounts of precious metals, like gold and copper, that are sparsely scattered throughout the mantle rock.
Okay, I want to use a culinary analogy here. Is the Earth basically deglazing a pan?
Deglazing a pan. That's interesting.
Think about it. You cook a heavy piece of meat in a hot pan, all the good, flavorful, concentrated bits get seared and stuck to the bottom. If you just try to scrape them out, it doesn't work.
Right. They baked on.
But if you pour in a splash of water or wine while the pan is scorching hot, the liquid instantly boils. The heat and the liquid work together to lift all that concentrated goodness off the bottom, dissolving it, and you pour it out as a rich, highly concentrated pan sauce.
I love that.
Is the Earth using pressurized water and extreme heat to lift the gold out of the mantle rock and transport it up into the crust?
That is a surprisingly elegant and highly accurate way to visualize it. The magma, acting as your pan sauce, is enriched with the dissolved gold. Because it is hot and relatively buoyant, it rises through the fractures in the crust.
And then what happens as it cools?
As it approaches the surface, it cools and the pressure drops. The supercritical water can no longer hold the dissolved metals, so the gold precipitates out, crystallizing into the highly concentrated veins that miners eventually discover.
Wow.
Understanding this geological kitchen isn't just a fascinating academic exercise. It has massive geopolitical and economic implications.
Because it tells us where to look.
Exactly. If we know the exact chemical signatures and tectonic recipes required to cook these mineral deposits, we know exactly where to point our geological surveys. As the world transitions to renewable energy, the demand for critical minerals like copper is skyrocketing. Understanding the Earth's plumbing system tells us where the resources of the future are hidden.
But the Earth is not just a giant rock kitchen producing minerals. It is a deeply interconnected and currently a very highly stressed biological ecosystem.
Greenly stressed.
And the recent climate reporting points to a massive, terrifying tipping point. We are looking at data showing that since 2010, the tropical forests of Africa have flipped from being a carbon sink to becoming a carbon source.
Which is an absolute tragedy.
Let's clarify those terms for everyone. A carbon sink means the forest is absorbing more carbon dioxide from the atmosphere through photosynthesis than it is releasing. It acts as a planetary filter.
Right, taking the bad stuff out of the air.
But a carbon source means the forest is now actively emitting more carbon into the atmosphere than it absorbs. How does an entire continent's forest ecosystem just flip its fundamental biological function?
It is a staggering and tragic ecological contortion, and it is driven by a combination of human activity and climate feedback loops. The tropical forests of the Congo Basin and surrounding regions have historically been one of the primary terrestrial lungs of the planet.
Pulling billions of tons of carbon out of the air.
Yes, but widespread deforestation for agriculture and logging is physically destroying the biomass. Furthermore, the climate is warming, bringing more intense and prolonged droughts.
And drought affects the trees that are left.
Heavily. When a tree is severely heat-stressed and lacks water, its rate of photosynthesis drops dramatically. It stops pulling in CO2. Simultaneously, as the tree struggles to survive, its respiration rate increases, meaning it is actively exhaling CO2.
Hey, trees exhale CO2?
Yes, during respiration. Add in the increased frequency of forest fires burning that dry timber, and suddenly the vast forest is dumping carbon into the atmosphere rather than trapping it.
And when a major terrestrial carbon sink flips, it obviously accelerates the global warming cycle. More carbon in the air traps more heat. But what I found profoundly shocking in the reporting is how they connected this abstract global atmospheric data to a deeply visceral, localized tragedy happening right now. gray whales are starving to death and washing up in the San Francisco Bay.
It seems disconnected, but it's not.
Help me connect those dots. How does a dying forest in Africa starve a whale in California?
This is where you see the true scale of the Earth as a single, indivisible system. The loss of a massive carbon sink in Africa directly accelerates the accumulation of greenhouse gases globally. The oceans, acting as a giant thermal battery, absorb roughly 90% of that excess trapped heat.
Okay, so the ocean gets warmer.
As the surface waters of the Pacific Ocean warm, it causes something called thermal stratification. Warmer water is less dense than cold water, so it sits on top like a lid.
A lid? Okay.
This lid prevents the normal, vital process of upwelling. Along the California coast, wind patterns usually push the surface water out to sea, allowing deep freezing, nutrient-rich water to well up from the bottom of the ocean.
And those deep nutrients act as fertilizer.
Exactly. That upwelled cold water is loaded with nitrogen and phosphorus, which feeds massive blooms of microscopic phytoplankton. The phytoplankton feed the zooplankton and the krill, which in turn feeds small schooling fish. It is the absolute foundation of the marine food web.
But the warm water lid stops the upwelling.
Right. Because the warming surface water creates that stratified lid, the cold, nutrient-rich water cannot rise to the surface. The upwelling halts. The phytoplankton blooms fail. The krill populations collapse.
And the whales eat the krill.
By the time you get to massive apex marine mammals like the gray whales migrating thousands of miles along the coast, their primary food source has simply vanished from the ecosystem. The starvation of a whale in the San Francisco Bay is an intimate, direct, downstream consequence of a stressed forest ecosystem thousands of miles away in Africa.
The plumbing of the planet is entirely connected.
It truly is.
And humanity's footprint inside that planetary system is full of profound paradoxes. Let's look at the paradox of human progress as highlighted in the reporting.
Oh, the data centers.
Yes. In North Carolina, there is explosive growth in the construction of colossal data centers. We are building these massive technological structures to power the artificial intelligence revolution, to process global financial transactions, and to house essentially all of human knowledge.
Which requires an insane amount of energy.
Exactly. They are consuming unfathomable amounts of electrical energy and fresh water for cooling. And what is causing serious local friction is that, due to highly controversial state tax break legislation dating back to 2010, the economic and utility data of these massive corporations is largely shielded from the public.
So the locals are kept in the dark.
Local residents don't even know the true toll these centers are taking on their municipal power grids or water reservoirs.
It is the classic municipal problem of unintended consequences colliding with rapid technological advancement. Back in 2010, local governments wanted to attract high-tech jobs, so they drafted legislation offering massive tax incentives and privacy shields to tech companies.
That seemed like a good idea at the time.
But a data center in 2010 was a fraction of the size and power density of an AI training facility being built today. The rapid evolution of the industry has completely outpaced the archaic legislation.
So they are essentially hiding behind old laws.
Now, you have single facilities drawing 100 megawatts of continuous power, the equivalent of a small city, saving millions in local taxes, but severely straining the utility infrastructure. The public is essentially subsidizing the energy demands of the AI revolution, while the true climate and resource impact is legally obscured behind corporate privacy laws.
It creates a massive systemic blind spot for regional planning.
A huge blind spot.
And then, on the absolute flip side of that paradox of progress, we have a bizarre situation unfolding in the Baltic Sea. The data shows that after World War II, the victorious Allied nations engaged in the mass dumping of captured German chemical and conventional munitions.
It's an environmental nightmare.
We are talking about roughly 1.6 million tons of explosive munitions, including vast quantities of deadly mustard gas and heavy metals just shoved off the back of ships into the ocean. The Baltic Sea seabed is a literal toxic waste dump.
But there's a twist, right?
There is. Marine biologists have recently discovered that crabs, fish, and other marine life are actively thriving in massive numbers on top of these rotting, leaking bombs. Nature is building ecosystems out of our weapons of mass destruction.
It is incredibly bizarre.
Now, I have to ask, are the crabs somehow thriving because of the explosive chemicals, or just because a pile of bombs provides a hard surface to live on in an otherwise empty underwater desert?
It is primarily the latter, though the biological reality is incredibly complex and ultimately quite dangerous. The bottom of the Baltic Sea in these dumping zones is largely featureless, muddy sand.
So there's nowhere to hide.
In a flat marine environment, any hard three-dimensional structure, whether it's a natural rock outcropping, a sunken ship, or a massive pile of artillery shells, acts as an artificial reef. It provides organisms with a solid surface to anchor to, crevices to hide from predators, and a complex environment to breed. So biodiversity naturally clusters around these munitions dumps.
So it's essentially underwater real estate.
Exactly. However, it is highly toxic real estate. Over the past 80 years, the salt water has been heavily corroding the metal casings of these munitions. The mustard gas, which is an incredibly nasty blistering agent, doesn't just dissolve harmlessly.
What happens to it?
It breaks down into toxic salts and chemical compounds that persist in the sediment.
Oh, no.
The crabs and bottom-dwelling fish may be physically thriving in raw numbers because of the structural habitat, but they're simultaneously absorbing highly toxic heavy metals, like arsenic and lead, along with chemical weapon degradation products, directly into their tissues.
Bioaccumulation.
Exactly, bioaccumulation. Nature is remarkably resilient and opportunistic, but it is actively absorbing our toxic legacy. And of course, as larger fish eat those crabs and commercial trawlers catch those larger fish, those World War II toxins slowly and inevitably work their way back up the food chain to human dinner tables.
It is a stark reminder that our environmental ledgers never truly clear. They just delay payment.
We always end up paying the bill.
And speaking of ledgers, it highlights how desperately we need coordinated, well-funded environmental management to handle these crises, from dying forests to toxic oceans. But the global funding simply isn't keeping pace with the reality of the threat.
No, it's falling way behind.
The reporting notes that the Global Environment Facility, or the GEF, which is a major multilateral trust fund, just held a pledging session for global climate, biodiversity, and pollution mitigation projects. They raised $3.9 billion.
Which sounds like a lot.
Now, to you and me, $3.9 billion sounds like an astronomical sum of money, but the reporting explicitly notes that this figure is a massive failure. It is actually $1.4 billion short of their previous funding cycle. How does global climate funding drop by over $1 billion during a period when the crises are demonstrably accelerating?
Because environmental funding does not exist in a vacuum. It is entirely subservient to the broader geopolitical reality. This severe funding shortfall is a direct, measurable reflection of current global anxieties.
Meaning nations are worried about other things?
The wealthy donor nations that typically fund the GEF are facing intense domestic economic pressures. Inflation, energy costs, but more crucially, they are facing a massive spike in global military tensions.
Right.
National budgets are finite. When the threat of regional wars in the Middle East, conflict in Eastern Europe, or rising tensions in the South China Sea dominate the security briefings, nations instinctively react.
They start buying weapons.
They immediately divert massive amounts of capital away from long-term abstract environmental commitments and funnel it directly toward short-term military readiness, defense procurement, and border security.
It's the ultimate triage. We are sacrificing the long-term survival of the planetary ecosystem in order to buy weapons and secure borders for the immediate future.
Precisely. It is a prioritization of immediate, localized security over existential global security. When nations feel physically threatened by their neighbors, concerns about ocean temperatures or carbon sinks become a secondary luxury.
Which brings us perfectly to the next major theme of today's deep dive, the human timeline. Because this constant underlying struggle over resources, territory, security, and borders is not a modern invention.
It's deeply ancient.
It is written into the very DNA of our species. And recent archaeological discoveries highlighted in the newswires are completely rewriting what we thought we knew about our ancient formative history. Let's look at a major discovery coming out of Tin Shemet Cave in the Levant, an area encompassing modern-day Israel and Palestine.
This is a really fascinating find.
Archaeologists have unearthed evidence from roughly 110,000 years ago, proving that Neanderthals and Homo sapiens didn't just exist at the same time in the same region, they actively interacted.
This specific discovery is truly monumental because it effectively shatters the old simplistic narrative that has dominated anthropology for decades.
The old narrative being that we just wiped them out.
Yes. The prevailing assumption was always a story of linear, brutal conquest. Homo sapiens, the cognitively superior species, migrated out of Africa into Eurasia and either vastly outcompeted the dim-witted Neanderthals for food or simply violently wiped them out in early tribal warfare.
But the evidence from Tin Shemet Cave shows something different.
It shows a deeply intertwined contemporaneous existence. They found evidence of shared complex technologies. Specifically, they found the extensive use of ochre pigments by both groups.
Explain ochre. Why is pigment important?
Ochre is a natural clay earth pigment, usually containing iron oxide, which gives it a rich reddish or yellowish color. Early hominins didn't use it for survival. They didn't eat it.
Right.
They ground it up to paint their bodies, dye their clothing, or decorate their cave walls. The use of ochre implies a leap into symbolic thought, artistic expression, and social decoration.
They were essentially sharing art supplies.
Laughs. It sounds entirely whimsical, but yes, essentially they were. It shows cultural transmission. But even more profoundly than sharing pigments, the excavations reveal that both groups developed remarkably similar formal burial customs for their dead in the same regional caves.
Wow, they buried their dead similarly.
Yes, which indicates incredibly complex social structures, cultural exchange, and a mutual recognition of the significance of life, death, and perhaps even early spirituality. They weren't just hostile passing ships in the night. They were neighbors observing, learning from, and sharing profound ideas with a distinctly different species of human.
It makes you look at early humanity with a sense of wonder. But just as we start feeling warm and fuzzy about our ancient history of interspecies cooperation and shared art, the data pulls us back to a much darker reality.
Ah, right. The Belgium cave.
Yeah, in a cave in Belgium, anthropologists found chilling, definitive evidence of Neanderthal cannibalism. And the reporting notes this wasn't just a desperate measure of starvation survival during a harsh winter.
No, it was targeted.
Right. The analysis of the bone fragments shows they were selectively butchering outsiders, specifically targeting women and children from competing Neanderthal groups. The bones have clear, intentional cut marks, where tools were used to strip flesh and crack open femurs to extract the nutrient-rich bone marrow.
It is incredibly grim.
How do we reconcile this? How do we hold both of these contradictory facts in our head? Were our ancient relatives peaceful, paint-sharing, spiritual neighbors, or were they brutal, cannibalistic raiders?
You reconcile it by realizing that they were exactly like us. You hold those ancient contradictions in your head the exact same way you hold the contradictions of modern humanity. Neanderthals were not a single unified monolith with one behavioral profile, any more than Homo sapiens are today.
So they had different cultures.
Just as modern nations can simultaneously engage in profound international humanitarian aid in one hemisphere and wage brutal, indiscriminate warfare in another, early hominins possessed the immense capacity for both deep in-group cooperation and horrific out-group tribalism.
Environment probably played a huge role, too.
Absolutely. The cannibalism found in Belgium likely reflects intense territorial defense, extreme resource competition in a harsh northern climate, or deeply ingrained tribal warfare. Meanwhile, the cooperation in the Levant reflects a different environmental dynamic, a crossroads of migration where resources might have been richer, allowing for tolerance.
So they were complex.
The ultimate takeaway is that Neanderthals were not simple brutes. They were as socially, emotionally, and psychologically complex and capable of both profound good and unspeakable violence as we are today. Human nature, in all its darkness and light, has been remarkably consistent for over 100,000 years.
And that consistency of human nature is also reflected in the lighter side of the archaeological reporting. In a separate dig, researchers have verified the discovery of the world's oldest known dice dating back roughly 12,000 years.
I love this discovery.
Long before the invention of the wheel, long before recorded agriculture or writing, we were sitting around playing games of chance. Fast forward a few thousand years to a dig site in modern-day Iraq, where archaeologists just unearthed a series of inscribed clay cylinders belonging to the legendary Babylonian king Nebuchadnezzar.
Who was famous for his building projects.
Right. The cuneiform inscriptions boast elaborately about his massive, grand construction projects in the city of Babylon, which perfectly matches the historical descriptions of his reign found in the biblical book of Daniel.
It is a wonderful grounding juxtaposition.
It really is.
The 12,000-year-old dice show the deeply universal human desire for leisure, thrill, and testing fate. The clay cylinders from Iraq show the equally universal desire of powerful leaders to project authority, conquer their environment, and cement their ego and legacy in stone.
We haven't changed much, have we?
Whether it's a prehistoric hunter rolling bone dice by a fire, or an ancient Babylonian king erecting monumental architecture to prove his own greatness, the core psychological drivers of human behavior, play, ego, dominance, legacy, remain entirely recognizable when we look in the mirror today.
And speaking of legacy and dominance, we have to talk about who gets the power to actually write that history, because it seems we are currently in the process of rewriting the maps.
Oh, this map debate is intense.
The recent historical data details a fascinating, highly contentious debate surrounding the Kunyu Wenguo Quantu. This is a massive, ancient Chinese world map. A prominent scholar named Shengwei Wang is arguing that the highly specific geographical information depicted on this map strongly suggests that the famous Chinese Admiral Zheng, he may have navigated his fleets to the Americas and Oceania in the 15th century.
Decades before Columbus.
Right, decades before Christopher Columbus ever set sail across the Atlantic.
This debate raises a critical structural point about how global history is formed, curated, and often suppressed by the victors, or in this case, by the dominant cultural narrative.
Because the Chinese fleet was massive.
In the early 1400s, the Chinese Ming dynasty possessed a massive, technologically advanced treasure fleet under the command of Admiral Zheng He. Their ships were significantly larger and more advanced than anything in Europe at the time. They were arguably the greatest maritime power on Earth, projecting influence across the Indian Ocean and the coast of Africa.
So what happened?
But abruptly, after his seventh major voyage, the Chinese imperial court made a devastating geopolitical decision. Fearing foreign corruption and domestic instability, they turned inward. They embraced strict isolationism, they dismantled the fleet, burned the navigational records, and essentially abandoned the world's oceans.
They had the technology to map the globe, and they willingly took themselves off the board.
They absolutely did. And that immense, sudden geopolitical vacuum allowed the smaller, hungrier European powers, Spain, Portugal, Britain, to eventually dominate global exploration and trade routes.
And because they dominated, they wrote the history.
Because the European powers wrote the subsequent maps and maintained their empires, the European narrative became the definitive, accepted history of the world. It led directly to the colonial era, which fundamentally shaped the modern borders and power dynamics we live with today. If the Chinese court hadn't turned inward, the global balance of power over the last 500 years would be entirely unrecognizable.
And we see the brutal physical reality of that resulting European expansion in another archaeological find reported this week. Down in southern Chile, researchers found a single 440-year-old silver coin that has finally allowed them to pinpoint the exact location of a lost settlement called Ciudad del Rey Don Felipe.
Which is a very tragic story.
It is. This was a Spanish colony founded in 1584, strategically placed to control and secure the Strait of Magellan, the vital shipping route at the tip of South America connecting the Atlantic and Pacific Oceans. And the history shows it was an absolute unmitigated disaster.
They underestimated the environment completely.
The Spanish colonists starved to death within 3 years because of the incredibly harsh, unforgiving environment and a complete lack of resupply. The neighboring indigenous populations famously renamed the site Port Famine. It's a stark reminder that those elegant colonial maps were drawn with a massive amount of blood, suffering, and hubris.
Exactly. The geopolitical ambitions of distant empires frequently overextend the physical, brutal realities of the geography they attempt to conquer. The Spanish crown was trying to exert control over a vital maritime choke point to secure global trade, but the sheer hostility of the environment defeated them.
They just drew a line on a map.
They viewed a line on a map as a mandate for control, but nature does not obey royal decrees.
Which brings us, inevitably, slamming right back into the present day. Because the legacy of those colonial maps and that eternal, unyielding human struggle to control vital geographic choke points is exactly what is driving the massive, incredibly tense geopolitical crisis dominating the front pages of the news today.
The situation in Hormuz.
Let's dive into the modern geopolitical web. And I want to note very clearly for you listening, we are looking at this unfolding crisis strictly through the lens of international geopolitics, strategic game theory, and global economic impact, exactly as it's laid out in the raw international reporting.
Right, just the facts on the ground.
Here are the established facts regarding the rapidly escalating standoff in the Strait of Hormuz. U.S. President Donald Trump has demanded that Iran immediately cease imposing tolls and boarding fees on international oil tankers passing through the strait.
And Iran's response.
Iran maintains a firm stance that the strait represents its sovereign territorial waters and that it has the absolute right to control and tax maritime traffic for security. In direct response to Iran's actions, the United States has announced a strict naval blockade of all major Iranian ports and has actively begun intercepting commercial ships that have paid the Iranian tolls.
Which is a massive escalation.
To try and defuse this powder keg, High-level trilateral peace talks were hastily arranged in Islamabad, Pakistan. Those talks involved key U.S. negotiators, including J.D. Vance, Iranian diplomats, and Pakistani intermediaries. But the data shows those talks have completely fallen through without a deal.
The deadlock remains.
The U.S. refuses to lift the blockade, and Iran remains utterly firm on controlling the strait and refusing to negotiate down its domestic uranium stockpiles.
To understand the sheer gravity of this standoff, you have to look at the geography. The Strait of Hormuz is the ultimate, indispensable global economic choke point. It connects the Persian Gulf to the Gulf of Oman and the open ocean.
Pretty narrow, right?
At its narrowest point, it is only 21 miles wide,
Yeah.
but the actual deepwater shipping lanes required for massive supertankers are only 2 miles wide in either direction.
Just 2 miles wide.
Yes. Roughly 20 to 30% of the world's total oil consumption and massive quantities of liquefied natural gas must pass through that specific 2-mile wide lane every single day. The strategic leverage here is immense.
So Iran is using that leverage.
Iran is utilizing its dominant geographic position overlooking the strait to exert maximum pressure on the global economy, demanding tolls to assert sovereignty. The U.S., utilizing its overwhelming global naval supremacy, is attempting to force Iran's hand through economic strangulation via a blockade. It is a classic high-stakes collision of land power versus sea power.
But here's what I don't understand about the mechanics of the standoff. If the U.S. Navy blockades the ports and actively intercepts ships, and the Iranian Revolutionary Guard demands tolls and threatens ships that don't pay, how does any oil actually get out of the Gulf?
That is the problem.
Who is going to risk sending a billion-dollar tanker into that mess? Who blinks first here?
That is the multi-billion-dollar question that is terrifying the global markets. And right now, neither side is blinking, which means a significant portion of the oil is simply not getting out. We are seeing a massive, immediate drop in commercial vessel traffic.
Because of the risk.
You have to understand the logistics of global shipping. Shipping companies and maritime insurers are incredibly risk-averse. If a region transitions from a tense waterway to an active, militarized blockade zone, maritime insurance premiums absolutely skyrocket overnight.
So it's just too expensive.
The cost to insure a hull against acts of war becomes prohibitive. So companies simply anchor their tankers in safe harbors and refuse to sail. And what's deeply crucial to watch here is the massive international friction this bilateral standoff is causing among traditional allies.
Right, the UK's position.
The reporting notes that the United Kingdom has officially and publicly declined to participate in the U.S. naval blockade.
That feels like a massive fracture in the traditional Western alliance. The US and the UK usually move in lockstep on maritime security.
It is a highly significant fracture. The UK leadership is reading the economic tea leaves and likely trying to actively insulate itself from the intense volatility. They want to avoid being dragged into an escalating kinetic conflict in the Middle East that directly threatens their own fragile energy security.
So they are looking out for themselves.
It shows how the traditional post-WWII bloc of Western allies is splintering and fragmenting based on deeply individual domestic national interests. When the global economic engine is threatened, nations look out for themselves first.
And the economic fallout from this standoff isn't theoretical. It is already hitting the ground hard and fast. The financial data released this week shows U.S. inflation has suddenly soared back up to 3.3% in March.
Which hurts the consumer directly.
Economists are tying the spike directly to record-high gasoline and diesel prices, which are reacting violently to the Iran conflict and the threat of restricted oil supply. Across the Atlantic, it is even worse. The European Union airline industry is issuing dire warnings of severe systemic jet fuel shortages.
Because of the drop in vessel traffic.
They are stating plainly that if the strait remains restricted, commercial flights across Europe could be permanently grounded within 3 weeks. And in Ireland, the reporting shows hundreds of local petrol stations have completely run dry, leading to citizens actively blocking major roads and highways in protest of the energy crisis.
This cascade of crises perfectly illustrates the extreme, terrifying fragility of our modern, just-in-time global supply chains. Over the past few decades, we have built a highly optimized, hyper-efficient global economy that relies on the absolute, uninterrupted flow of goods and energy.
There's no backup plan.
Companies don't store massive reserves of fuel or parts anymore because storage costs money. They rely on the next ship arriving exactly on time. There is virtually no slack left in the system.
So when one piece stops, everything stops.
When a geopolitical standoff occurs thousands of miles away in a narrow 21-mile strait, it doesn't take months to feel the downstream effects. The disruption travels at the speed of global markets. A naval blockade in the Persian Gulf translates directly into a canceled family flight in London, a painful spike in inflation at a grocery store in New York, and a completely empty gas pump in Dublin, all within a matter of days.
We are deeply, uncomfortably tethered to one another's instability.
Extremely so.
It is also incredibly tightly wound, and you can see the deep historical echoes of empire still playing out in how these modern nations attempt to secure their military positioning around these vital choke points. Look at the reporting regarding the Chagos Islands.
The UK and Mauritius situation.
The United Kingdom was on the verge of officially ceding sovereignty of the Chagos Islands, an archipelago in the Indian Ocean, back to the island nation of Mauritius. It was being hailed as a major final step in the historical decolonization process. But this week, the UK has suddenly paused and indefinitely delayed the handover plan, citing intense behind-the-scenes opposition from the United States government.
And if you look at a strategic map, you immediately see why the United States intervened. The Chagos Islands are home to Diego Garcia, which is a highly secretive, absolutely vital U.S. and U.K. military airbase and naval facility right in the center of the Indian Ocean.
So they need that base right now.
In a time of dramatically heightened military conflict in the Middle East, with blockades in Hormuz and shifting alliances, the United States military requires absolutely secure, undisputed, sovereign outposts from which to project air and naval power across the hemisphere.
So history takes a backseat to strategy.
The stark geopolitical necessity of the current moment, the need for a fortified island fortress, has entirely overridden the moral and historical process of decolonization. Once again, geography dictates military strategy, and strategy dictates history.
It really does. The map is the ultimate game board. But physical geography and shipping lanes aren't the only battlegrounds anymore. Let's pivot to the digital realm for our final major topic today. Because technology, specifically artificial intelligence, is rapidly becoming the ultimate, uncontrollable wild card in human affairs.
The Hungarian elections are a perfect example.
Look at the recent national elections in Hungary. The reporting shows that longtime Prime Minister Viktor Orban has officially conceded defeat to the opposition leader Peter Magyar. That is a massive political shift in Central Europe. But what is truly alarming election watchdogs is how the campaigns were conducted.
It was a digital mess.
The elections were plagued by the widespread, targeted use of AI-driven deepfakes and hyper-realistic disinformation aimed at manipulating voter perception and smearing candidates in the final hours of voting.
We are rapidly entering an era that some analysts are calling mutually automated destruction in the information space. Generative artificial intelligence now allows for the mass, inexpensive generation of highly convincing, entirely fabricated audio and video at a scale and speed we have never encountered before.
It just floods the zone.
This directly threatens the very foundational bedrock of democratic elections. Democracy relies on the premise of an informed electorate debating a shared set of facts. But if voters cannot trust their own eyes and ears, if the electorate cannot agree on a shared, objective baseline reality because half the videos on their feed are AI fabrications, the democratic process fundamentally breaks down.
It's terrifying on a macro level.
The macro-level implications for political stability across the globe are absolutely terrifying. We have built weapons of mass deception.
And the micro-level implications, the impact on personal safety, are equally disturbing. The legal reporting highlights a massive, unprecedented lawsuit filed against OpenAI by a victim of severe stalking.
This is a really chilling case.
The woman claims that her abuser used ChatGPT to analyze her online presence, generate manipulative messages, and track her locations. The lawsuit alleges that the AI platform blatantly ignored multiple internal safety flags, fueled her abuser's paranoid delusions, and actively, algorithmically aided in the stalking process.
This case is a horrifying example of the collateral damage of rapid technological deployment. It shows that as Silicon Valley corporations rush to deploy these incredibly powerful generative AI technologies to capture market share, the ethical guardrails and safety protocols are failing under real-world pressure.
It's moving too fast.
At the macro level, as we saw in Hungary, AI has the capacity to alter the fate of a nation's government and destabilize a society. At the micro level, as we see in this lawsuit, it can cause profound, tangible, terrifying harm to a single individual when it lacks rigorous ethical oversight.
We just can't keep up.
Technology is currently advancing vastly faster than our legal systems, our ethical frameworks, or our psychological ability to regulate its consequences. That widening gap between capability and control is perhaps the single most defining characteristic of the 21st century.
Okay, let's take a moment, step back, and pull all these massive threads together. Today, we have seen the incredible heights of our potential. We've seen how humanity is pushing further out into the cosmos, riding rockets at Mach 32, measuring the very fabric of the expanding universe, and inventing rust-proof steel and specialized nuclear crystals just to navigate the dark void of space.
We are capable of so much.
We are relentlessly tracking the deepest geological forces of our planet, finally understanding how supercritical water and crushing magma cook up the gold in our microchips. We are unearthing our ancient past, proving that Neanderthals and sapiens shared art, rituals, and humanity long before we shared drawn borders. We are a species capable of incredible vision and cooperation.
But there is a flip side.
And yet, despite all this profound knowledge and soaring capability, we remain deeply, stubbornly, sometimes tragically entangled in the exact same tribal conflicts we have fought over for millennia. We are still fighting over resources.
Still drawing lines on maps.
We're still choking off maritime shipping lanes and blockading ports to exert dominance. We are sacrificing our environmental future to build weapons, and we are using our most advanced, brilliant digital tools, not just to discover truth, but to mass-produce fabrications and lies. We are a species capable of photographing the entire Earth from the far side of the moon, but we still cannot seem to figure out how to equitably share the Earth itself.
It is the ultimate enduring paradox of humanity. We are simultaneously enlightened and tribal. We possess the engineered tools of gods, capable of altering the atmosphere and exploring the stars, but we retain the fearful territorial instincts of our ancient ancestors sitting in a cave in Belgium.
Which brings me to a final, provocative thought for you to mull over as you go about your day. 400 years ago, the brilliant astronomer Johannes Kepler sat down with early telescopes and painstakingly drew pictures of sunspots on pieces of paper.
A pioneer.
He was trying to solve the mystery of a 70-year period where the sun mysteriously went dark, attempting to link cyclical solar activity to the harsh winters of Earth's climate. He was a human being looking up, trying to understand the massive, distant light that gives us life.
And now we do the reverse.
Today, NASA does the exact opposite. They look down. They use the VIRS satellite system orbiting in the cold blackness of space to take highly detailed, continuous nightlight imagery of the Earth. They track the shifting, glowing sprawl of human cities to measure economic volatility, to map the devastating impacts of regional wars, and to track our slow transition to new energy sources.
Reading the map of humanity.
They are quite literally reading the story of our civilization, written in the electric light we spill outward into the night sky. If someone or something looks at the light radiating from our planet 400 years from now, what story will those lights tell?
That is the big question.
Will they see a unified, evenly glowing globe powered by sustainable energy, the bright lights of a species that finally figured out how to live together and expand out into the stars? Or will they see the fragmented, isolated flickers of a species still sitting in the dark, fighting over imaginary borders on a map? Keep questioning the world around you. Thanks for joining us on this deep dive.
Enjoying Artificially Informed.
Hit subscribe and share it with a friend.
From the left, the right, and straight from the algorithm.
Thank you.
Welcome to the debate. Imagine paying for your groceries in Berlin, right? Only to find the price has just doubled.
Yeah, overnight.
Overnight. And why? Because 21 hours of, failed diplomacy in Pakistan just shut down a stretch of water 3,000 miles away.
We tend to assume the global economy is this, digital borderless machine.
Oh, absolutely. The illusion of a seamless global supply chain has definitely been shattered here. I mean, we rarely think about the physical infrastructure of trade until, someone turns off the tap.
And the tap has been turned off.
Completely. We are dealing with the immediate, cascading, planetary fallout of those marathon peace talks in Islamabad between the U.S. and Iran.
Which collapsed completely, yeah.
Right. They collapsed. And in response, the U.S. has declared a naval blockade of the Strait of Hormuz. The sheer scale of this is just staggering. Oil is trading well above $100 a barrel, and we are seeing a 13% decline in global daily oil flows.
And inflation is just spiking worldwide.
Exactly. Today, we are looking at this crisis from a planetary perspective because this is an asymmetrical shock hitting literally every continent. My position is that strict deterrence, which includes this drastic naval blockade of Hormuz, is a painful but fundamentally necessary recalibration. We just have to protect global supply chains from state-sponsored extortion.
Right. But at what cost?
Well, if we don't secure long-term geopolitical stability now, we are practically inviting a permanent hostage situation down the line.
See, the problem I have there is that the cure is arguably more destructive than the disease. Unilateral brinkmanship and maximum pressure tactics, they are fracturing the global economy in real time.
You think so?
I mean, yes, this blockade is disproportionately devastating the global south. It ignores the deeply interconnected nature of regional sovereignty. You are taking this intricate, deeply integrated planetary system and, well, hitting it with a sledgehammer just to prove a geopolitical point.
Okay, but to understand why the sledgehammer was deployed, we need to look at what actually happened in Islamabad. The U.S. delegation, led by Vice President J.D. Vance, Steve Witkoff, and Jared Kushner, flew to Pakistan and engaged in 21 grueling hours of diplomacy.
Grueling is definitely the word.
Yeah, and they went in good faith, but they hit a wall of impossible preconditions from Iran. The Iranian delegation demanded the immediate unfreezing of assets, but more critically, they dictated terms regarding Israeli military actions in Lebanon. They made that a prerequisite for maritime security.
Right.
And if you allow a state to control a vital maritime choke point through arbitrary tolls and the threat of violence, you leave the entire planetary economy vulnerable. The U.S. blockade strips away that leverage. It basically says, you cannot extort the globe.
You call it a sledgehammer deployed for a good reason, but the failure in Islamabad was entirely predictable. I mean, it's the inevitable result of an approach that fundamentally relies on coercion rather than genuine multilateralism.
How so?
Well, the United States is acting almost entirely alone here. Just look at the UK. British Labour leader Keir Starmer explicitly refused to join this blockade.
True, but
And when your closest, most historic maritime allies refuse to participate, it tells you something fundamental about the viability of the strategy. The U.S. is projecting power, sure, but by leveraging maximum pressure, it has triggered an asymmetric global supply shock. The IMF is warning that 45 million more people are being pushed into hunger directly because of these supply chain disruptions.
I hear that, but the deterrence is meant to protect those very nations from arbitrary extortion. Let's unpack those 21 hours in Islamabad, specifically the demands being made by Iran's chief negotiators, Parliament Speaker Mohammad Baghir Ghalibaf and Foreign Minister Abbas Araghchi.
Okay.
They essentially held global maritime trade hostage over a ceasefire in Lebanon. Think about the mechanical reality of Lebanon right now. The Lebanese prime minister recently admitted that his government is politically present, operationally absent.
Which is a tragic reality of their domestic situation. I mean, no one is denying that.
It is, but it explains exactly why the Iranian demand is in bad faith. What the Lebanese prime minister means is that the state cannot control Hezbollah, the militant faction operating within its own borders. The sovereign government just doesn't control the military reality on the ground.
Right, but
So for Iran to tie the free flow of global shipping to a conflict where the host government admits it has no operational control, meaning the U.S. couldn't enforce a guarantee even if it wanted to, it's just a transparent stalling tactic. Iran isn't trying to solve the Lebanon crisis. They are using a fractured state as a shield to justify blockading a global trade route.
I see why you think that. But let me give you a different perspective. You're treating the negotiation over the Strait of Hormuz as if it exists in a vacuum. You cannot separate regional conflicts in the Middle East. They are inextricably linked.
They are linked, sure, but you can't hold the world hostage over it.
You call it a stalling tactic, but from a planetary integrated perspective, it is simply a geopolitical reality. You cannot seriously ask Iran to guarantee the normalization of maritime traffic right on its doorstep, while its regional allies and interests in Lebanon are under intense bombardment. We just witnessed the deadliest day in Beirut, with over 300 fatalities.
Yeah.
True stability requires comprehensive regional peace. It requires addressing the whole board. Iran isn't misreading the board by bringing up Lebanon. They are pointing out that the board is literally on fire.
I understand that perspective, but treating the global economy like a hostage negotiation where you pay the ransom by granting unlinked regional concessions, it only guarantees future kidnappings.
Future kidnappings?
Yes. Think about the mechanics of what you're suggesting. If the international community agrees to this framework, if we say, okay, we will force a policy change in Lebanon, so you will allow oil tankers to pass through Hormuz, what happens next year?
Well, diplomacy is ongoing.
But they will find another regional grievance. Maybe it will be in Yemen, maybe in Syria, and they will threaten the strait again. You are literally incentivizing the weaponization of global trade routes. That is the exact mechanism of state-sponsored extortion, and if you validate it once, it becomes permanent policy.
But your argument assumes the U.S. blockade has actually stopped the extortion. It hasn't. It has just shifted the burden of the pain to nations that have absolutely nothing to do with the Israel-Lebanon conflict or U.S.-Iran relations.
It's a short-term pain for long-term stability.
Is it? This is where we have to translate this asymmetric supply shock into reality. When we say asymmetric, we mean that a rich Western nation can afford to print money, tap strategic petroleum reserves, and weather the storm of $100 oil, but developing nations cannot.
Right.
Look at Japan, for instance. They rely on the Middle East for 95% of their crude oil. This isn't just an inconvenience for Tokyo. Japan is facing the physical cessation of its modern economy.
Look, I don't downplay the severity of the shock. The U.S. is not immune to it either. I mean, our inflation rate hit 3.3% in March, driven almost entirely by these record gasoline prices.
But 3.3% inflation in the U.S. is a completely different universe than what is happening in the global South. Take Mozambique. The cost of aviation fuel there has surged from $769 to over $1,500 per ton.
That is a massive jump.
A massive spike like that literally paralyzes regional logistics. You can't fly cargo, you can't distribute medical supplies. Economic development simply freezes, and the contagion is spreading upward. The European airline industry is warning of severe jet fuel shortages within 3 weeks.
Yeah, the 3-week warning is alarming.
Right, we are looking at the prospect of grounded fleets across an entire continent. When you enforce a blockade like this, you are starving vulnerable populations and grounding global mobility just to prove a doctrinal point about who controls the water.
But the fact that a localized maritime dispute can double aviation fuel costs in Mozambique and threaten to ground European airlines in 3 weeks, that proves exactly why the blockade is necessary.
Wait, how does that prove it's necessary?
Because it highlights how utterly dangerous it is to leave the global economy vulnerable to a single point of failure controlled by a hostile actor. The Strait of Hormuz is only 21 miles wide at its narrowest point. A quarter of the world's oil passes through it.
Exactly, which is why you negotiate.
But the global supply chain is basically an intricate line of dominoes, and the strait isn't just a piece on the board, it's the table those dominoes are resting on. If we abandon the blockade right now just to save European airlines and Japanese energy imports today, aren't we just greenlighting Iran's strategy to pull the table out from under us tomorrow?
The problem with the domino analogy is that it assumes the rest of the world will just sit there and let Washington and Tehran decide when the dominoes fall. They aren't waiting.
What do you mean?
The assumption behind this blockade is that it will eventually force compliance and restore the Western-led maritime order. In reality, it is actively accelerating global fragmentation. The rest of the world is frantically building alternative systems to bypass exactly this kind of Western military and financial dominance.
I hear this argument often, but the traditional mechanisms of global finance and trade are still the only ones capable of handling planetary scale. The sanctions are biting because the US dollar and the SWIFT banking system still underwrite global commerce.
I'm sorry, but I just don't buy that. Let me tell you why. If you look closely at the financial mechanisms being deployed right now, that dominance is fracturing. There are highly credible reports that Iran is actively considering using stablecoins to collect tolls for passage through Hormuz.
Yeah, let's explain how that actually works, because it's a massive escalation.
Exactly. So a stablecoin is a digital cryptocurrency, usually pegged to the value of a fiat currency like the US dollar, but it operates on a blockchain.
Right.
Practically, this means a Greek or Indian oil tanker passing through the strait wouldn't wire a toll fee through a clearinghouse in London or New York, where the U.S. Treasury can track it or freeze it. They would simply transfer a digital token directly to an Iranian wallet in seconds.
Wow.
Yes. By utilizing cryptocurrency for sovereign tolls, they completely bypass the SWIFT banking system, the global messaging network that banks use to move money across borders. This completely blindsides Western financial surveillance. The rise of alternative financial systems like stablecoins for state-level tolls shows that the global South is actively building a firewall against Western financial dominance.
But using cryptocurrency to extort maritime trade isn't a sustainable financial system. It's essentially a digital ransom drop.
But it functions. And the fragmentation isn't just happening with sanctioned states. Western allies are breaking rank when the economic desperation hits. Think about the public rhetoric over the last few years regarding phasing out Russian energy.
Right.
Despite all those bans, the European Union has quietly ramped up Russian LNG imports, liquefied natural gas, by 17% early this year, spending nearly 3 billion euros.
And just to clarify for the listener, LNG is natural gas cooled to a liquid state so it can be shipped on specialized tankers rather than pumped through a pipeline. When pipeline gas from Russia was heavily sanctioned and shut off, Europe had to rely on these ships, mostly coming from the US and the Middle East.
Right. And now that the Middle East supply route is severely compromised by this blockade, Europe has to keep the lights on, so they are quietly buying Russian LNG again. It proves that when the planetary economy is stressed to this degree, physical, economic desperation overrides Western political alliances.
That's a fair point.
Your blockade isn't deterring extortion, it's actively driving the world toward alternative, unregulated networks and forcing allies to fund adversaries.
I'll give you this. Global fragmentation is absolutely happening. The economic stress from this blockade is fueling protectionism everywhere. We are seeing it far beyond the Middle East. Look at Latin America right now.
Yeah, the situation there is tense.
Very. Colombia and Ecuador recently got into a massive spat involving a 100% import tax. When resources get tight, nations pull up the drawbridge. They protect their own. I concede that point.
Okay, so you see the risk.
I do. But to suggest that the entire globe is going to permanently transition to an unregulated shadow economy of stable coins and illicit LNG shipments, I think that fundamentally misreads human behavior and political accountability.
Well, a structural shift doesn't mean every transaction instantly moves to the blockchain. But the infrastructure is being laid down right now.
But a structural shift toward shadow economies implies a complete abandonment of transparent democratic governance, which simply isn't playing out on the ground. People do not want to live in unregulated shadow systems when the economy gets tough.
Not necessarily shadow, just alternative.
Even so.
Take the historic election in Hungary. It just occurred.
For 16 years, Viktor Orban led Hungary. He was deeply aligned with authoritarian models and actively flirted with alternative Eastern alliances. Exactly the kind of fragmentation you were talking about.
Sure.
But he was just ousted by Peter Magyar in a landslide. Why does that matter to our discussion? Because when economies falter, when inflation bites and everyday systems degrade, citizens eventually reject authoritarian-aligned leaders and demand transparent, democratic accountability.
Well,
They want integration with stable, rules-based systems, not isolation in a fragmented shadow economy. The resilience of democratic, transparent systems in the face of economic stress is highly underestimated.
the Hungarian election is a fascinating internal European dynamic, but you cannot map voter behavior in Budapest onto the geopolitical reality of the global South.
Why not? The human desire for stability is universal.
Yes, but the options are different. A country like Mozambique or a heavy energy importer like Japan cannot simply vote their way out of a 100% spike in aviation fuel caused by a U.S. naval blockade.
That's true.
When you force nations into a corner where they literally cannot afford to feed their populations or fuel their supply chains, because of Washington's deterrence strategy, they have no choice but to find another way to operate.
Right.
And this is the critical point. Once those alternative planetary supply chains and financial systems are built, once the stablecoin infrastructure is normalized and the new shipping lanes are established, they do not just disappear the moment the United States decides to lift the blockade. You are fundamentally altering the geopolitical architecture of the planet, and not necessarily in America's favor.
I don't disagree that the architecture is shifting, but it forces us to ask what kind of architecture we actually want to live within. If the alternative to Western financial dominance is a planetary system where vital choke points are taxed via untraceable cryptocurrencies by states that sponsor regional instability, that is a recipe for global anarchy.
But the current approach isn't working either.
The blockade and the hardline diplomacy we saw from the U.S. delegation in Islamabad are attempts to break this cycle before it becomes fully entrenched. It is an incredibly painful intervention, but establishing that the global circulatory system of trade cannot be subjected to sovereign extortion is necessary. The ultimate goal here is a resilient, rules-based global order. You cannot build a stable planet on a foundation of appeasement and shadow finance.
And I maintain that applying unilateral military and economic coercion to complex, interconnected regional crises is a failed paradigm. It is fracturing the globe, it is starving vulnerable populations in the developing world, and most importantly, it is failing to achieve its primary objective of peace.
Well, it's definitely a clash of paradigms.
Exactly. The 21 hours in Islamabad collapsed because you fundamentally cannot separate a maritime choke point from the burning regional conflicts surrounding it. Until we approach these crises with genuine multilateralism, which means understanding the legitimate security concerns and interconnectedness of all regional actors, rather than just applying a military tourniquet to a trade route, we will continue to see these catastrophic shocks to the planetary system.
It seems we are arriving at a profound point of convergence, even if we vehemently disagree on the remedy. We both recognize that the planet is now so deeply intertwined that a localized maritime dispute in the Middle East instantly becomes a crisis of global hunger, massive inflation, and a catalyst for shifting financial paradigms worldwide.
Absolutely. The era of uncontested Western economic hegemony is facing an unprecedented stress test right now. The fallout from the collapsed chats in Islamabad proves that we can no longer view these events strictly through a Western lens.
No, we definitely can't.
The ripple effects we are seeing in Africa, in Asia, in Latin America, they are actively reshaping how the global order will reorganize itself for decades to come.
And as alternative economic systems emerge and new political leaderships rise and fall, from the streets of Budapest to the trade corridors of South America, there is clearly much more to explore in how our planetary home adapts to these massive disruptions.
Definitely.
We'll leave it there for today. Think back to that image of the global economy as a sprawling, interconnected network. Whether you believe we are performing life-saving surgery to remove an extortionist threat or inflicting blunt force trauma on an already fragile system, one thing is certain: the entire machine is currently under immense strain, and the whole world feels the shock.
That's it for today's Artificially Informed.
Nope. Thanks for spending your time with us.
Yeah.
Stay sharp, stay curious. See you next time.